GM, everyone. So my name is Megabyte and I'm Polygon Developer Advocate. And today we are going to build an NFT which will be a cross-chain NFT, and we are going to build it using router protocols CrossTalk library. And for the starting, let's start with the fundamentals first. Like first, we should understand what is cross-chain, then what is router CrossTalk library, and then we can definitely get into the development. So now let's get started with the fundamentals. So the first one is, what is cross-chain? What is chain interoperability? Chain interoperability or cross-chain is the capability of different blockchain networks or systems to interact and exchange information and resources with each other. In simple terms, it means different blockchain systems can work together as a unified network instead of operating in isolation. For example, one blockchain could be used to store financial transactions, while other could be used to store information about supply chain. If these two blockchains are interoperable, or they can work together to create a new application that combines the benefits of both. Chain interoperability or cross-chain is a complex and highly technical aspect of blockchain technology, requiring a deep understanding of cryptography, consensus algorithm, and network protocols. The implementation of interoperability protocols, such as Router Protocol, provides a common language and infrastructure for the transfer of information and assets between networks, enabling the creation of more interoperable and connected blockchain ecosystem. The continued advancement of chain interoperability standards and protocols will play a vital role in shaping the future of blockchain technology and its impact on various industries and society as a whole. So I hope you got that basic understanding of what is chain interoperability and how it's going to benefit the whole blockchain ecosystem and the Web3 ecosystem. So now let's move forward and let's learn about what is Crosstalk Library by Router Protocol. Router Crosstalk Library is an extensible cross-chain framework that enables seamless transition across the multiple chains. In simple terms, this leverages router's infrastructure to allow contracts on one chain to communicate with the contracts deployed on some other chain. It consists of three important functions which together helps to build a cross-chain application. The first one is the request to desk or request to destination. This function is used to send cross-chain requests with some message from the source contract to the gateway contract on the source chain. This message will then be forwarded to the gateway from the gateway contract to the gateway contract on the destination chain. Next is the handle request from source. It is used to send the request with some message from the gateway contract to the application contract on the particular chain. This where it executes all the function defined in it and then will return the data. And the last function which we have is handle crosstalk acknowledgement. When the execution is completed on the destination chain, all the acknowledgement, whether the transaction are executed or not, is sent through the gateway contract of the destination chain to the gateway contract of the source chain. And then these acknowledgements are sent to the application contract, which have a function named handle crosstalk acknowledgement, and transfer this acknowledgement to this function, which help us to identify whether the functions on the destination chain got executed or not. So now let's learn about like how are we going to use crosstalk library in a contract. So this is the current roadmap, like how the flow will work from our contract on the destination contract. So the first, like in the source chain, we will have a gateway contract and the source contract. Same is goes for the destination chain. We have a gateway contract and a source contract. First, when we execute a transaction for transferring our NFT or ERC721 token, it will be requesting the transaction to the gateway contract. Then gateway contract moves the transaction to the router chain, which validate or verifies the transaction and then move it further to the destination chain. This destination chain gateway contract then send this transaction to the source to the destination contract on the handle request from source function, which then handles all the parameters and then executes the transactions for the source chain. Now, after this transactions got executed, this gateway contract sends the acknowledgement to the gateway contract on the source chain, which consists of whether which transactions got executed or not. Then this gateway contract again sends the whole acknowledgement to the handle crosstalk acknowledgement function on the source contract. This help us to identify which functions got executed. So this is how we are going to build our whole dApp like a contract. So now let's move forward for the development. Hello everyone. So now let's get started with our development. So first of all, move to your directory wherever you want to set up a project. Like I'm going to set up it on my desktop. Then create a directory named cross ERC721 and yep, and then move towards that for the CRC, and then the first step would be npm init dash y. So it will initialize the npm in your directory, and then it's time to install dependencies. Spoiler alert, like there will be a lot of dependencies which we are going to be installing over here. And the first one is the hardhead, of course. It's the smart contract development environment. It helps us in compilation and deployment of the smart contract and also in testing. So first install hardhead and then let's wait for a few minutes. After it will be installed, we will initialize the hardhead project, which will set up a boilerplate and configurations for the hardhead. And then we can move ahead with the installing more dependencies and working on a contract. So let's give it just 2 minutes. And now as it installed, so now let's initialize the hardhead project npx hardhead and then done and create a TypeScript project. It will and then press enter for the root directory and git ignore and install all the dependencies which are required by the hardhead to set up the correct environment for your project. So the first dependency which hardhead is going to install is a Numeric Foundations hardhead toolbox. So let's wait for it till it gets installed. So now all the first dependency is installed. Now it's time to install some few more dependencies which will be required by our project. Since it's a TypeScript project, so we'll be requiring to install these dependencies, developer dependencies for the functioning of TypeScript accordingly for a project. And two more dependencies apart from TypeScript is the .env for gathering the environment variables in different files and ethers for interacting with the contract. So let's wait for a few more seconds, I guess, to get them installed, and then we can get started. So it's all of them are installed. Now it's time to set up your hardhead configuration environment. So let's open it up on our VS Code. So let's get started with the hardhead configuration for our environment. And let me paste a script for you guys, and then I will explain it what we are doing over here. So hardhead configuration.ts is a file where it defines like how the hardhead environment will work for our project. First, it will be requiring some dependencies, and then we will import our private keys like the environment variables, which will include a MetaMask wallet address private key, then alchemy Polygon Puma testnet RPC URL, and then Polygon scan key, like the block explorer key, then the Avalanche RPC URL, and the Avalanche snowtrace key, which is the block snowtrace is the block explorer for the Avalanche Fuji testnet. Next, we we defined our Solidity version, which is the latest which we are using, 0.8.18. After that, we initialize networks which we are going to use in a hardened environment. The first one is the Mumbai, and the second one is the Fuji testnet. Why we have specifically defined the chain ID over here because of purpose of this tutorial. I will explain you guys about it later. And then at last we initialize our EtherScan API keys, where we are giving up the Polygon Mumbai scan key, or like Polygon scan key over here, and the Avalanche Fuji testnet, the snowtrace.io key over here. So this sets up your whole hardware configuration environment. The only thing which is left for the environment purpose is the environment variable. And just create a new file like this over here, and then you need to initialize like this. So what we are doing it is we are first pasting our Alchemy Polygon Mumbai test RPC URL, then our MetaMask private key, then Polygon scan key, then Avalanche notice key, and the Avalanche URL key. You can find all these keys to specific URLs. I will define them in the documentation. And then uh, this is all for your environment setup for the hard hat and for your development. Now it's time to build the contracts. So let's get started with that. So let's get started with the contract development. So first, in your terminal, install the dependency OpenZeppelin contracts. This These contracts are audited numerous times, and they are pretty reliable and straightforward for a development, and we will be using ERC721 contract for our NFT development. So let's get it installed, and then we can move ahead with some few other dependencies, and these dependencies uh, are for the cross-chain working of a contract. The first one is the EVM gateway contract, and the second one is the router protocols, CrossTalk utils. And now we are done with that. Though, if you get any error while installing all these dependencies, then you should uninstall the ethers. So just uninstall it if there is any issue in the installation of the dependencies. Now we are done with all the dependencies which we are going to require. So now let's get started with the contract. Uh, and first delete this contract and from the directory, and then create a new contract with name cross ERC721.sol. Now let's initiate our contract with all the dependencies and a Solidity version. So we will be importing EVM gateway contracts and router protocol crosstalk contracts. And then we have initialized a contract with the name cross ERC721, which is extended to ERC721, provided by OpenZeppelin, and crosstalk application, which is provided by EVM gateway. So now let's initialize our state variables. First of all, with these, and here we go. And let me just stop it for a bit in a yeah, disable. And yeah, over here we got our state variables. The first one is the admin, like the address of the owner of the contract. Second one is the gateway contract. So now if the gateway contract address over here signifies, like if we are going to deploy this particular cross ERC721 contract on Polygon, then the gateway contract address which we want in this is the gateway contract address on Polygon, not on anyone else, on any other chain or destination chain, the Polygon chain itself. So, and the second one is the destination guest limit, like it is required for the handle handling the cross chain request on the destination chain. And The next variable we initialize is the mapping, where we are mapping through the chain type plus chain ID and the address. So what it will contain, like this particular cross ERC721, it's going to be deployed on different chains. So we are going to store all those contract addresses with their chain type, which is defined by the router protocol itself, and the chain ID with the contract address in the format of bytes. So that's why we are doing the mapping over here. And why do we require it? It's basically required for the verification purposes, whether the incoming request from any gateway contract is from a particular contract only or not. So now the last is the struct. It's the transfer params, like which will contain NFT ID, basically the token ID of the NFT which we are going to transfer to another chain, and the recipient address, like a recipient address in the format of bytes, which we are going to transfer to the another chain. So these are the state variables, and now it's time to set up our constructor. So let's get started with that. Let's initialize the constructor, and here it is. So the parameters which a constructor is going to accept while deployment is the gateway address, which I defined above, then the destination gas limit, like destination chain gas limit, and the token ID. Like for the testing purpose, we are minting a token ID to the deployer only. So any token ID like one or two, whatever you want. And also we are going to set the admin as the deployer. So this is what our constructor is. And now let's get started with the actual functions which we are going to use to transfer and handling the receive request and then the acknowledgement. But before that, we first need a function which is used to set up set these contracts, like set the mappings over there. So let's get started with that first, because without that, we will not be able to interact with our gateway contract. So now that's this, and yeah, set contract on chain. So what this function do? The first, it maps all the contract addresses of the contract on different chains. Like this contract is deployed on Polygon Mumbai testnet, and then it is deployed on Avalanche Fuji testnet. So both of those contracts on the both chains will contain each other addresses. And why is that? It's because of the verification purposes and the and the requirement by the router protocol cross-chain crosstalks. Next, what we have here is the chain type, like which is defined by the router protocol itself, and then the chain ID, the standard chain ID of the particular chain, and the contract address. We have done an initial security requirement over here that this can only be called by a message.sender, which is admin, and then we are setting the contract on the mappings using the variables we got from the parameters. Now let's get the one of the most important function, the transfer function, for transferring a particular NFT from Polygon to Avalanche or vice versa. So let's get started with that. So we got a transfer function over here. And what does it do? It's transfer the NFT from the source chain to the destination chain, like whichever the chain we define for transferring. Like it accepts several parameters which are crucial for the particular function. First one is the chain type, then the chain ID, and then the expiry duration in seconds. What does it mean? It means like the particular transaction, like the transferring will be expired. This function will be expired if it not get executed in these amount of seconds on the destination chain. So like I sent it from Polygon to Avalanche and it not get completed in 20 seconds, then the whole transaction will be reverted back. So we are not looking forward to work with this particular variable. So we will initialize this with a big number, like a million of seconds, so that it won't cause any issues while testing over here. Next, we have destination gas price. This the gas price is variable from time to time for every chain. Therefore, we have to the correct and like gas price over there, because if the gas is lower the amount than required, then the whole transaction will be reverted back, and the gas which is spent will not be returned. So therefore, to save the cost, we are accepting the gas price, which is variable, and then we are accepting the token ID and the recipient address. So the first check which we do is checking whether this contract is it should be set on a particular mapping. Then we initialize transfer params, memory variable over here with the NFT ID or token ID, and the recipient address. We are using crosstalk function 2 bytes to convert our recipient address from the format of address to bytes. And the next check is for the ownership check of the particular NFT ID or token ID which we are going to transfer. So this check is done by the owner of function, which is provided by ERC721. So now we are burning our NFT on this particular chain. So what happens over here is, as we previously uh, learned, like this particular NFT, if we want to translate from Polygon to Avalanche, then a Polygon NFT will be burned, and the same NFT with the same data will the data of that NFT will be transferred to Avalanche, and that particular token ID of the NFT will be minted over there on the Avalanche. So it will be the identical, but it will not be like the whole NFT is transferred. It will be like first it burned over there and then it's minted over there. So this is how the whole things work. Now we initialize the payload and encoded it. It will contain our transfer parameters, and then we initialize our expiry timestamp, like in how many seconds we are going to expire this, and then we have the destination chain params. So it will contain all the destinations parameters which will be required by the router protocol library. The first one is the gas limit, then which is the state variable, then the price from the parameters, then the chain type and the chain ID, which is also the parameters. Now, this is the first request which we are going to make to our gateway contract. So what does it do is, like, using the crosstalk utils library, we will send a request with which is a single request. Like, we are not sending multiple requests to multiple functions, and we don't want any particular data to be reverted back. So it's without acknowledgement. So the first parameter which it takes is the gateway contract. The crosstalk library requires a gateway contract, which you are going to send the request to, and then the expiry timestamp, like at what block timestamp the whole transaction should be cancelled. Then the destination chain params, like the parameters of the destination chain, and then our contract address on that particular chain, which we are going to transfer it, and the payload. Like, payload will be containing the transfer parameters of a particular NFT. So this is what we are going to transfer to the crosstalk library. Then it will be transferring to our gateway contract on the source chain, and that gateway contract will transfer it to the router chain for verification, and the router chain is going to transfer it to the gateway contract of the destination chain. Then that destination gateway contract will transfer the request to the contract address, this contract, to the on the destination chain. So for handling that particular request, we will also requiring to have a handle request function in the same contract itself. So let's get started with that now. And a request from source. So as you know, like, this request accepted to this particular contract from by the gateway contract. So what is it going to contain is, like, what the gateway contract is going to send is the contract source contract address, like from the Polygon chain, like the contract address from the Polygon chain, if it's on the Avalanche. Then the payload, like the data received from the source chain in bytes, and the source chain ID and the source chain type. So these are the parameters which the gateway contract is going to send to our contract on the destination chain to handle the request from the source chain. Now, the first thing first is the checking whether this gateway contract is the same contract which we have defined in our contract only or not. Like it should not be any other gateway contract or any other chain or right. So we first check like the message dot sender, the contract which is calling is the gateway contract or not. Then we check whether this contract which is sent, like the source contract address, it does do we have that in a mapping or not? With how do we check that? So the mappings, like using the source chain ID and source chain type. Next, we decode the payload to our transfer parameters so that we can use it to mint. Now over here, the mint function, this is not recommended now. It should be safe mint, but for the sake of tutorial purpose, we are using mint. So what it will do, so it will mint the NFT ID or the token ID, which is burned on the source chain on the destination chain to the recipient address. And that recipient address wasn't bytes, so we are using CrossTalk library to convert it into address format. And then we will mint it. And now we are returning empty string because we don't want any data to be returned on the source chain. So this was our handle request from source. Next, the only thing is left for us is the acknowledgement function, which will be handled on the source chain. So let's get started with that. So we got our handle crosstalk acknowledgement. So what does it do is the handle the acknowledgement received by the gateway contract for the function executed on the destination chain. So what happens when the functions are executed on the destination chain, those acknowledgement, like whether the transaction is executed or not, is sent by the gateway contract of the destination chain to our gateway contract on the source chain. And then that source chain gateway contract send it to us on the contract. Why we do that is to know like whether the transaction which we were thinking about, like it get executed or not. So this is the requirement and the required function in our contract. For a testing purpose, we are not handling any acknowledgement, like we are not doing something with that, or so therefore we have initialized this function empty. But as it is required, then we definitely have to initialize it. So what does it contain? It contains the event identifier, like when this request was created, for which type of event, and then the execution flags. This execution flag is an array of Boolean values. Why this is Boolean? Because, and why is this array? The first one is Boolean is because it just said that whether this function is executed or not, and it is array because we can transfer multiple requests in a single transaction. Over here we have used single request as single request without acknowledgement. As you can see over here, this single request without acknowledgement. But we also have an option to send multiple requests. Therefore, it have an array which will contain whether this function on the transaction on the destination chain got executed or not, or the transaction got executed or not. Like it can contain true, 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 false, true, true. So you will know which transaction was not executed over there. Then we got the executed data, like whatever the data is returned from the destination chain to our source chain. So this was all about our contract for the cross-chain NFT, and now it's time to deploy it. So let's get started with that. First, move to your deploy folder in deploy script in the script folder, and then you can remove all this and let me paste the script for deployment and the verification of a contract on the Polygon scan and on the snow trace. So here we got our script for the deployment and verification. So let me explain what we are doing it over here. First, we are importing ethers from Hardek. Then we are initializing a main function or any function you want to name it. Then we are first getting the network on which we are going to deploy, whether it's Polygon or Avalanche. If it's Avalanche, then it should be this particular chain ID. And if this is Avalanche, then the gateway contract address, which is predefined by the router team, will be this. And if it's not the Avalanche, and then it must definitely be Polygon. So therefore, the gateway contract address should be this. And same as goes for the token ID. Why we are taking one and two separately is because if we transfer the same token ID, it is already minted on the destination chain, then it will the transaction will not get executed. So we should mint token IDs differently. Like if it's the token ID 1 is on Polygon, then it should not be on the Avalanche. Then we over here we deployed we get a contract from the get contract factory, and then we deploy it with the parameters like the gateway contract, and we are setting the gas limit 1 million. So like it should not be reverted back due to any gas limit or gas price. Then we set a token ID over there. Um, After that, we deployed it and we console log the deployed address. Then with gap of 40 seconds, we will start verifying our contract on the Etherscan and the Notice IO. So let's get started with that. For that, now move to a terminal, write npx hard run scripts and run scripts and deploy.ts network. The first network which we are going to deploy on is the Mumbai network. So let's get started with that. And if you're on the VS Code, what you can do is just click on the add button over here, then wait for a few seconds, and then you can write the script command again, npm hard run scripts deploy.ts network and Fuji. So over there it will be deploying and verifying on Polygon on this terminal, and on this it will be deploying and verifying on our Fuji testnet. So let's wait for it till all of them get executed. Here you can see our contract is deployed over this, and we got an error over here because the contract got already verified because the same contract exists on the Fuji testnet, and it was deploying on or through the same private key, so it gets verified automatically. If it's not verified for you automatically, then it will be showcasing something like this: your contact address and the Polygon Mumbai URL. So now, congratulations, your contract is now deployed and verified on both Polygon Scan and Fuji testnet. So let's now interact with the contract and transfer your first NFT from Polygon to Avalanche testnet, or we can use Avalanche to Polygon. Now open up your browser and move to mumbai.polygonscan.com. This is the block explorer for Polygon Mumbai testnet, and on another tab open testnet.snowtrace.io. This is the block explorer for Avalanche Fuji testnet, and then copy up your contract addresses for Mumbai and then paste it on your Polygon scan. Same goes for the Fuji testnet. Copy it from here and then paste it here. Now move to contract. You can see the right green tick, which means that the contract is verified. And then click on the right contract button. Click on connect to Web3, MetaMask, and okay, you may ask to get approval for connecting. You may approve it. And then the first thing first is set contract on chain. Then the chain type of Avalanche is 0, chain ID is 43113, The contract address is this. Copy it, paste, right, and then we will get a pop-up from MetaMask and approve it and confirm transaction. Same goes for the Polygon, same goes for the Avalanche. We need to do it first before transferring any assets to any place. Now contract, write contract, connect to Web3, MetaMask. It will be asked for switching to the network, to Avalanche C chain, that is Fuji network, and connect to Web3, MetaMask. Okay. And if you don't have the Fuji network in your MetaMask, then just click on this button at the footer, and then set contract on chain, chain type 0 for Polygon, address is 8001, and the contract address will be this. So let's copy it from here and then paste it here. Now just wait and confirm the transaction. Over here, let's confirm. Transaction is confirmed. You can check, and you can check this transaction also. So this transaction is a success. And what about this? Let's refresh once. It's also a success. So both of the contracts on Polygon and Avalanche have the addresses of both contracts on Polygon and Avalanche. So now that's a good thing. Now it's time to transfer an NFT from Avalanche to Polygon, as we are on the Avalanche testnet. So let's transfer it from Avalanche and then transfer cross-chain. But before that, let's check what do we have here in our contract right now. As you know, we have token ID 1 minted in our Avalanche chain contract. So let's check it. Who is the owner of it? And you can see this address 0x1c is the owner. And if we check for the Polygon, does it contain 1? So what we will get, it doesn't contain, it's an invalid token ID. But if we do 2, which we minted, then we can see it's the same owner, like the deployer. So now let's move to write contract, transfer cross chain. Let's give it a 0.1. Chain type 0, chain ID 0001. Duration, let's put it to 1 million seconds. And destination gas price, like for the Polygon gas price right now will be, let's check what's the gas price. It's 500, like more than 500. So let's put around 600. And it's in gray, so we need to convert it in gray. So few more zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9. And NFT ID is 1. And the recipient address, copy any address from your from your MetaMask wallet, and then click, and you can see which address we copied, 0x56, and write. Now confirm. Let's wait for this transaction to get completed, and soon we will have a NFT. And yeah, we have an NFT from Avalanche to Polygon. Let's check it in a contract, Polygon chain. And you can see we have our address, which have the token ID 1, which was on the Avalanche chain, and now it's on Polygon chain. So congratulations, guys. You have just transferred your first NFT cross-chain from Avalanche Fuji testnet to Polygon Mumbai testnet. So yeah, this is all for today. See you guys soon in the next one.